And now for a tangent and secant paradox. Let's say you're given to solve the integral of tangent of x times the secant squared of x. Now in this case, you have two different strategies. You can go with the u equals tangent of x, du is secant squared of x, dx. This whole thing turns into u du, which becomes 1/2 u squared plus a constant, or 1/2 tangent squared of x plus c. What a beautiful answer. Not that tricky at all. But maybe you had thought, you didn't immediately think, oh, it's all tangents and a secant squared. Maybe you looked at this as secant of x times secant of x tangent of x. Maybe I put the secant first, and you thought, oh, this is some number of secants with a secant tangent at the end. And you said, well, I'll set u equal to secant of x, and the derivative is going to be secant x tangent of x dx. And so the secant of x becomes u, and the secant x tangent x dx becomes du. That's easy. It's 1/2 u squared plus a constant, or 1/2 secant squared of x plus c. Now the problem is, are these the same? Because if they're not the same, then one of them has to be the right answer and one of them has to be a wrong answer. What goes wrong? And in fact, actually, if you take the derivative of this up here, the 2 cancels out with a 1/2, and we're left with tangent times, the derivative of something squared is 2 times that thing times the derivative of that thing. And you just get tangent times the derivative of tangent and secant squared, tangent times secant squared. That one works. Well, what about this one? If we say 1/2 secant, that's the derivative of this. The 2 cancels out with a 1/2. We're left with secant times the derivative of secant, which is secant tangent. Secant times secant tangent is secant times secant tangent. Secant squared tangent of x. They both work. But the question is 1/2 tangent squared of x plus c equal to 1/2 secant squared of x plus c? And if so, does that mean we can subtract the c from both sides, multiply both sides by 2, take the square root, and get the tangent is the same thing as the secant? Answer is no. No, they're not. What went wrong? Here's what went wrong. What we have is, you know that the sine squared of x plus the cosine squared of x is 1. This long-standing trigonometric identity, it's basically the Pythagorean theorem. If we divide everything by the cosine squared of x, it will still be an inequality. Basically, we divide both sides by cosine squared of x, and what do we get? Sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared. This is the underlying identity that's going on. That is to say that if we have 1/2 secant squared of x plus c, that means that this is the same thing as 1/2 tangent squared of x plus 1 plus c. Because secant squared is tangent squared plus 1. And if you multiply this out, you get 1/2 tangent squared of x plus 1/2 plus c. And this is what's going on. The trick is, when we subtracted c from both sides, we were assuming that the constant over here was the same as the constant over here because we used the same letter. But they're not. It turns out that this 1/2 sine squared of x plus c is equal to 1/2 tangent squared of x plus a different c. And in fact, if you think about it, so plus c prime, let's say, what it is the c prime on this side is 1/2 plus c. So the c on the second one, on this one, is 1/2 more than the c on the other. And this again is just something, it's a paradox. It seems like a contradiction. It's not a contradiction. Well, you certainly can't, this is a mistake. You can't subtract c from both sides because they're different. One of them is 1/2 more than the other one. And it's just another case of, if we were using a math book, you could do a problem completely right, look up the answer in the back, and see a completely different answer. You could see that you had gotten 1/2 tangent squared of x plus c, whereas the supposedly right answer in the back is 1/2 secant squared of x plus c. And the difference is that there's this relationship between tangent squared and secant squared. They differ by a constant, and our integrals are only giving us answers up to a constant. And so there's often many different ways that look completely different to write down the same answer for these sorts of problems.